Warm welcome, everyone. Come on in, get your notebook, pencil, pen, whatever you need to write with. This is math from the void. Math coming at you out of nowhere. And today we have a problem from the 1989 AP Calculus BC exam. It's very approachable from anyone in AB Calculus. So if you're not in BC, that's okay. If you are in BC, this should be very easy. But I really liked this problem when I saw it. So here we have a function such that the second derivative is a linear equation, 6x plus 8. And so that means it's a polynomial, which means that f of x is a polynomial, because the derivative of polynomials are polynomials. All right, so let's see what we have to do. I really like this question in part A. It wants us to find f of x, like the equation of f of x, but the condition they give us is very interesting. I don't see this very often. They're giving us initial conditions in a very interesting way, because in order to go from f double prime to f, you would first have to take an integral, and then you arrive at f prime plus c, right? And then you would have to take another integral and use another initial condition to get f of x, because there would be another plus c. But where's the initial condition for each of these things? Well, the initial condition for the derivative is this part. It says tangent to the line, which means it has the same slope as this line. So that kind of gives you an initial condition. We'll have to work with it, but that's the logic there. And then for f of x, the initial condition is simply the point that it's tangent. Okay? So let's do the antiderivative. Integral of f double prime. That's going to be equal to the integral of 6x plus 8. And so that's going to give us 3x squared, remember, raise the power, then divide by the new power, plus 8x plus c. Now, we don't know exactly what this derivative is equal to, but it is the slope of the function. So if we take this line and we find the slope of that line, it will have the same slope since it's tangent to that line. So what is the slope here? The slope is 3. If you solve for the y, you get y equals 3x minus 2. That has a slope of 3. So what this is telling us is that when x equals 0, we still have to use this as well. When x equals 0, the slope equals 3. So basically 3 equals 0 plus c. And that gives us an equation for the first derivative. Now we have to do this process again. And they've set us up really nicely with the coefficients of the polynomial. It's like really easy to do the power rule. We have to do the antiderivative again to get f of x. So f of x is going to be the integral of f prime. So we have to take the antiderivative of 3x squared plus 8x. Isn't that just such nice coefficients, like really nice for us to work with? Super easy. Raise the power, divide by the new power. You just get x cubed, nice and clean, plus 4x squared plus 3x. Again, plus c. Now we have to use this initial condition, which is the point. When x equals 0, y equals negative 2. Okay? So it's going to be 0 plus 0 plus 0. So in the case of polynomials, generally we're going to, if we have it in this nice standard form, and then when you plug in 0, you're just going to get the constant value. So this answers our question. What is f of x? F of x is x cubed plus 4x squared plus 3x minus 2. Okay, let's move on to part B. Part B says find the average value, which means we're going to have to take another antiderivative. So we're integrating a whole lot in this problem. Find the average value on this closed interval, so from a to b. And for those of you who remember how to find average value, if not, go look it up, go do what you got to do. We're preparing for the AP exam. Cannot be missing out on these formulas. Important. Take the integral from -1 to 1 of f of x, because that's our a to b, and then divide by the width of the interval, or the size of the interval. So that's 1 minus -1, b minus a. All right, so we're basically taking the integral from -1 to 1 of x cubed plus 4x squared plus 3x minus 2, and then we're dividing all that by 2. Is that right? Did I get the function correct? Yeah. Okay, let's take another antiderivative. So 1/4 x to the 4th plus 4/3 x to the 3rd. Here's where they make you do a little bit of work. Plus 3/2 x squared minus 2x. But we're just evaluating from -1 to 1. And then dividing that by 2. So this is pretty easy to just plug in a 1. We are going to have to do some fraction work, though. So we're going to have 1/4 plus 4/3 plus 3/2 minus 2. And then when we plug in -1, all of the even powers will turn -1 into a positive. But the odd powers will be flipped to a negative. So as I said, we're just going to have some fraction work here. Nothing crazy, especially since we haven't spent much time on this question. Make sure you're comfortable with fractions, man. Like, you just gotta. So common denominator here is going to be 12. We're going to have 3/4 plus 3 12s plus 16 12s plus 18 12s minus 24 12s. We're going to do all that minus, what do we have here? 3 12s minus 16 12s plus 18 plus 24. And then all of this is over 2. Okay, so just add it up. You get 34, that's 10, that's 13, minus, what do we have here? That's 2, 26, 29 over 12. And all that's over 2. So we're going to have -16 over 12 over 2, which is -4/3 over 2, or just -2/3. All right, that's the average value of the function. So this function does have some negative value when x is negative. Kind of makes sense. And by the time it gets to 1, we have some positive value, but I guess not enough has accumulated. I would sketch this for you guys, but I'm not sure exactly what the sketch looks like. And it's not easily factorable by grouping. I just know that it has some kind of a y-intercept here at -2. And I also know that the slope is 3 at that point because it's tangent to this line. So it's going upwards in some sense. But see how it's still in the negative space. So by the time it gets to 1, right, what's f of 1? This is going to be 8 minus 2 is 6. So by the time it gets to 1, it goes pretty high up there. But from -1 to 0, it probably spends a lot of time, down here in the negative space. So the average value on that interval is -2/3. Okay, that was a quick function problem. I really liked it because it sort of hides this information, this initial condition about the first derivative, which you need in order to get your plus c. If you don't get that, you can't really get to f of x, and so you can't get any other points at part A. Right. All right, that'll do it for today. I'll see you next time in the void.